Go through another example. Let's see what it says. It says we have 75 students participated in an online speaking test to prove proficiency in English. The times taken by each student to complete their self introduction was recorded. So the time that each student took talking about themselves. You know, when you get there, they say, tell us about yourself. And then you start speaking about yourself. So now this thing recorded the time that each student took talking about themselves, right? All right. We don't really have to understand this part of the question. I always tell you that. I'm just reading it because I have to, right? If I don't, then it will be improper. But then when you're in an exam setting, you don't always have to. You can go and check what the question wants, then you come back looking for the data that would help you to get what you want. So anyway, the times taken by the students, blah, blah, blah. The following table shows the times in minutes that the students took. Did we get helped by reading this part of the question? No, we didn't get helped. It didn't help us in any way, okay? Whatever happened, we don't care what happened for them to make this table. We really don't care. What I'm going to do is, when I look at the problem, I can look at the table and I see it's a frequency distribution table because I can see the frequency there. I can see frequency there. I can see my data as time, whatever the time was. I don't really care. But then I can see there's time and I can see there's frequency, right? Frequency is telling me how much, how many, right? Exactly. So now this is a frequency distribution. Let's see what they want. Okay, so remember what we always do. When we look at a table, we look at two things. One, yes, is it a frequency distribution or a probability distribution? This is a frequency distribution. It's not talking about probability. Fine. And then the other thing we look at, the data in the table, is it grouped or ungrouped? Here I can see it's grouped because I can see the interval here. From 1 to 2, 2 to 3, 3 to 5, whatever. Keeps going. All right? So anyway, that means now, that means the only thing that I can do right now, that means when I deal with the stuff, I know I'm dealing with grouped and I know I'm dealing with the frequency distribution. Okay, let's go for it. Now, what do they want me to do? Calculate the estimates of the mean and standard deviation. Okay, every time I know that if they want standard deviation, I have to get mean first. Okay, so now we are doing a higher level question. There's something in this question now. It is that we now have grouped data, right? We now have grouped data in our frequency distribution. So how do we then go ahead to find what we want? Now we know that if we want mean for group data, we make a table. I mean, we have to go ahead and make a table. Remember that the formulas we use, let's go to the table. Let's go to our MF19, our formula booklet. Here's our formula booklet. Remember that we go to the page that talks about statistics and we go to the list. This is standard deviation. This is mean. Okay, it doesn't say it, but I've told you 9 billion times that this is going to be the mean, the X bar. Mean is the X bar. And the first one is when you don't have grouped, when you don't have frequency distribution, which is going to be this. But we have, so we're going to cancel it. And even for standard deviation, the first one is when you don't have frequency distribution, which we do have. So we're going to leave it. So we're going to be dealing with these two, right? For the mean and standard deviation. So I'm going to go ahead. I should get the mean here, but I know that for me to use this, when I have grouped data, I first make my table. So I have to go ahead and make my table, right? Okay, let's go. Let's go. We have to go and make our table. So now what is our table going to have? You remember the 4 things that we need for the table for mean, right? When we have group data, first we put the time, right? Here's our time. And since it's an interval notation, we don't have to put the boundaries, okay? We can have it like just like this. Now, what is the next thing we're going to put? What is the next thing we're going to? It's the mid interval, okay? The mid interval value. So mid interval value, which will be our X because it's group data, right? We don't know who to use as our X. Remember our table with those 4 important things. Let's go. So here's the first one. 1, then mid interval value now. Then after mid interval value, which is the X, we can now have our frequency. But now, since we also need standard deviation, we are now going to put for X squared as well, right? Once we get the X, we're going to put for X squared as well. And then now what we are going to do is to then put for frequency F, then we are going to put for XF, okay? Or X times F. And then finally, we will put for X squared times F. Okay? X squared times F. Right, there we go. So here's our table. Let's go for the stuff. What is the time? The time says 1 less than or equal to x, which is less than 2. Then 2 less than or equal to x, which is less than what? 3. Then we have 3 less than or equal to x, which is less than 5. Then we have 5 less than or equal to x, which is less than 7. Now, what's the mid value here? Mid interval value is going to be, since we already have a continuous scale, it ends at 2, starts at 2, ends at 3, starts at 3, ends at 5, starts at 3, at 5. So it's a continuous scale. So we can just go ahead and find the mid interval value by saying 1 plus 2, then divided by 2, right? So it'll be just 1 plus 2, then over 2. Then here it will be 2 plus 3, then over 2. Then in here it is 3 plus 5, then over 2. Then here it is 5 plus 7, then over 2. What do we get here? What do we get in each of these? 1 plus 2 is 3. Over 2, you get 1.5. This is 5 over 2, you get 2.5. This is 8 over 2, you get 4. This is 12 over 2, you get 6. So here I have my mid-interval values, right? Which are my x values. Then I now need x squared. How do I get x squared? I just square. So it's 1.5 o squared. I get 2.25. Okay? So if you want to be saying 1.5 o squared, you get 2.25, right? Then, or we can just be putting the solutions. Still fine. 2.25. In here, it is 2.5 o squared. Although it doesn't kill us to put the calculation for these things. It does not kill us. So we'll be saying 1.5 squared. Then in here, 2.5 squared. Then in here, 4 squared. Then 6 squared. All right, so yes, these solutions would be, this here would have our 2.25, and then we would have 2.5 squared being 6.25, right? Then we would have, okay, 4 squared being 16, 6 squared being 36. So here we have our values. Now the frequencies, we always take them from the table, right? 15, 32, 22, blah, blah. So let's put them. So this is going to be 15, 32, 22, 22, and 6. Then now we can have it. Let's start with x times f, then x squared times f, right? X times f would be 1.5 times 15. Remember, x is right here, it's the mid interval. Then f is the frequency. So 1.5 times 15, we get 22.5, right? And then we say 2.5 times 32, we get 80, right? Then 22 times 4, we get 88. Then 6 times 6, we get 36, because we say this 6 times this 6, right? We are multiplying x and f. Now we are multiplying x squared and f. So it's 2.25 times 15. So 2.25 times 15, we get 33.75. So 33.75. Then here we now say 6.25, then times the frequency, which is 32, we get 200. Wow, beautiful. Then now we say x squared 16 times 88, we get 1408. 1408. Then here we say 6 squared is 36. So 36 times frequency, which is 6. So we say 36 times 6, we get 216. So get 216. So now that we have it like this, we now put our sum. If you remember, if you go to the last question, what we didn't have grouped data. But we said we summed up frequency and then x times f, which is the same thing we do. We don't sum up the data, the x and the x squared and the time, we don't sum that up. But frequency going up, we sum it. So right now, frequency going up should be summed because we're going to need them in our calculation. So we're going to we'll put our last row. Remember the last row that should have the sums. Okay, we can have it like this. Here's the last row. Now we can sum the frequency. Frequency, we've been told that there were 75, wasn't it? Let's see. Yeah, 75 students. If you add, you must get 75, okay? Then let's add x squared times f. We'll say 22.5 plus 80 plus 88 plus 36. We get 226.5. We get 226.5. All right. Then now we say 33.75 plus 200 plus 1408 plus 216. We get 1857, 1857.75. This is going to be the solution. Then now what do? We have summed it. So remember that my columns were not long enough. We're not big enough, but this was the summation of f. Then this one here is the summation of xf. Then here, this is the summation of x squared f. Okay? Summation of x squared f. Be careful. Do it this way. Okay? Make them big. Make your columns bigger because you're going to need to put this summation thing. Okay? Mine were not big enough, clearly. Now, what are we going to do? These columns, we don't add them, right? These ones, we don't add the data. The only time we add x and the x squared is when we are dealing with something that is not in a frequency table. So let's go for it now. We've got all the stuff. Now we're just going to put in our things. We would say now x bar, which is the mean, is the summation of xf over the summation of f. You can go check the formulas in MF19, which is the summation of xf. We have it is 226, so 226.5 over the summation of f was 75. So what do we get? Now look at how easy it is. 226.5. Don't make a mistake now. Divided by 75, we get 3.02. Wow, great mean. Now let's go to part 2. Mean standard deviation. So now let's go for standard deviation. We say standard deviation is equal to, you can go and check, it'll be the summation of x squared f over the summation of f minus mean squared. You could check that. Okay, you can go to your MF19. I'll go there, and we always pick the lower one, right? This one. This is the one which we want. The second one on the lower one. This is out. Okay, but remember, we are using this lower one because it is for it is for frequency. When you have a frequency distribution, when you have the table, you use the second one. Okay, number 1 is when you don't, right? Number 2 is when you have a frequency distribution. So we have a frequency distribution, we use number 2, and we don't use the first one, we use the second one. The second one is when we have group, it is always the one we use in calculations, right? Which is the one we are now doing. You see how it works with our table? It agrees with our table, this second one. So now we're just gonna go, let's put in the things. Standard deviation is going to be the square root of, what is it now? X squared f, it is 1857.75. 1857.75. Hopefully, if I made a mistake on this one, you can forgive me, but you can put the things that, the true values, right? But you get the concept, right? Minus the mean. The mean, we got it as 3.02, so minus 3.02 squared. Then we can go for it now. Then we can go for it. So now what would we do? We say 1857.75, 1857.75, these divided by 75, we get an answer. Then we say minus 3.02 squared. We get an answer. Then we say the square root of that is 3.9559, blah, blah, blah. So this would be 3.96. Okay, it's 3.96. That's the standard deviation. Now, if they had asked for variance, variance would be standard deviation squared, right? Which would be the one before we square root. So we don't put the square root. So it'll be like 1857.75 over 75, then minus 3.02 all squared. There's no square rooting, okay? There's no square rooting. And that would have been 15.649, so it'll be like 15.65, okay? That is what we would have. And that is all, and thanks, that's it. Don't forget this. This is your final solution. Anyway, now you've seen it. I hope you've enjoyed. Goodbye. See you in the next video. Be careful. Make sure you do everything according to plan. All right? And make sure you stick to 3SF. This is for SF. We could have it as 16.7 rather. All right? All right. Bye.